So last lesson on electrolysis today, well, last lesson at home, because we do have a required practical to do when we go back to school. So electrolysis of brine, I want you to do your task, my daily task, at least 10 questions, and then I want you to write down what is brine. I'll be telling you the answer in a minute, I just want to know what you think. So write it down and I'll see you in a second. Hi Year 10, so we're going to be doing some electrolysis today. I have got this little beauty here to make sure that it works because the batteries just weren't powerful enough. So electrolysis of brine. I know there's loads and loads of words that you've got to learn for this topic. You've got electrolysis, electrolyte, anode, cathode, so many words. Here's another word for you to learn, brine. Now, brine appears in exactly 3 places in your life at the moment, okay, just 3 places, and one of them is this lesson. So aren't we blessed that we have this lesson, electrolysis of brine? But it doesn't actually tell us what brine is. So here's another hint. Okay, tuna chunks in brine. This is the second place that you will see the word brine. So it's something to do with fish, but we're not quite sure. And the last place you're going to see it is when you have got Dr. Emilius Brown and Miss Eglantine Price bobbing along at the bottom of the beautiful briny sea in the beautiful film Bedknobs and Broomsticks. You can watch that after this lesson if you like. It's a really good film. But it's the one place that actually tells us what brine might be. And brine is seawater. It is a solution of sodium chloride being the salt most commonly found in the sea. Now, I have got my little assistant here who is going to show me, who's going to help show you what happens when we electrolyse brine. Now, I have got about 25 mils of saturated solution of sodium chloride. So what I did is I put lots of salt into the water and stirred it until it wouldn't dissolve anymore to make it a saturated solution. I have got my 2 electrodes here, so let's clip them on. Sorry, did you want to help me? Can you hold this electrode in the water for me like this? Can you put your safety glasses on as well to do it? Good boy. Okay, so you need to hold the electrode in the water. Don't let it touch the bottom. Okay, and then I'm going to pop my electrode in the water as well. Now, it's really important the electrodes don't touch, so can you hold it still? Okay, nothing's happening, so I'm going to turn on the power pack. And what you should be able to see, can you see all those bubbles coming off? Sorry, can you look and see the bubbles coming off? Is there lots of bubbles on the electrodes, on the pencils? We are using the graphite in the pencils to be our electrodes, by the way. It's not the pencil itself. So yeah, so what we're doing is we're making lots of bubbles. And does it smell? What does it smell like? Okay, that was really quiet. Does it smell like a swimming pool? He's nodding, okay. So Theodore's gone all shy for the video. But yeah, so it's smelling like a swimming pool. So, Year 10, what gas do you think is being made? All these bubbles, don't touch the electrodes, darling. All these bubbles coming off are gases being made. Which gas is being made that smells like a swimming pool? Okay. Thank you, Theodore. You've helped me a lot. Can you go find Daddy now, please? Yeah? Good boy. Right, tell me when you're ready. Sorry, my cameraman was a little bit faster than I was there. So, okay, so what's going on in here? We've seen that electricity has made gas. How's that working? Well, what we're going to do is we're going to look at what's happening in the molecules, okay? So, I have got about 7 water molecules here, H2O, 2 hydrogens, 1 oxygen. And into that, I added salt, sodium chloride, okay? In it goes. And what happens to that sodium chloride is it breaks apart. And we are making the sodium cations, positive ions, and the chloride anions, negative ions. Okay? Water, by the way, doesn't stay like this. It breaks up as well into hydrogen ions, which are cations, and hydroxy, OH minus, anions. And they don't just break up and stay broken up, they break up. So this one's broken up. It might then remake with another one. This one might break up. That happens all the time in water. So what I'm going to do is I'm going to remove the water molecules because these are just spectators for this. They're there, the reaction's happening around them, but they're not taking part. So hopefully you remember the word spectator from earlier. And this is what we've got left. Okay, we've got our ions left. We have got our positive cations, hydrogen, sodium. Okay, and they are going to be attracted to our cathode. Our cathode, negative electrode, is giving off lots of electrons. But only one of them can get the electron. Sodium's really reactive, and we're doing a reactivity series next lesson, so don't worry if you don't understand reactivity. Sodium's really reactive, which means it loses its electron really easily. It's not going to want to pick up electrons. Hydrogen is less reactive than sodium. So what happens is the hydrogen gains the electrons, turns into hydrogen gas, and floats away. Off it goes. Okay, so now we're just left with sodium cations. Our anions, on the other hand, are going to go over to our anode, our positive electrode, which is going to suck up electrons. Which electrons is it going to suck up? The more reactive elements this time. I know it's a bit complicated to remember. Just remember brine makes hydrogen and chlorine. So chlorine gas is made because chlorine is more reactive, and again it's a gas, it bubbles away, off it goes, and that leaves hydroxide behind. So we now have sodium cations and hydroxy anions. They react together, bam, and we are left with sodium hydroxide because we had hydrogen and chlorine, but they've floated away. So we need to write down half equations for that. So let's just take a look at the bit of paper now. Okay, so this reaction is the reaction that we've just looked at. Pause the video and have a go at balancing it. Okay, so we had 2 sodium chlorides, 2 waters, we made 2 sodium hydroxides, hydrogen and chlorine. Okay, so that's our balanced equation for what we've done here. Higher paper, have a go at balancing the half equations as well. So don't forget that in water, our sodium hydroxide is still going to be floating around as ions, okay? So those are the spectator ions, if you're asked. Spectator ions, they stay in the solution. So have a go at balancing these for the reactions at the electrodes and label which electrode it is as well. Okay, so this is at the cathode. And we've got 2 hydrogen ions and 2 electrons making hydrogen gas. And at our positive anode, we've got our negative chloride anion attracted to the positive. We've got 2 of those because it makes Cl2, and that means we must also have 2 electrons. Okay, so that's the half equation for it. Okay, good news is we are nearly done. There's just one more thing I have to tell you about. Okay, purification of copper. What you have is a copper sulfate solution and 2 copper electrodes. Okay, now your copper electrodes are actually, one of them is going to be impure. Okay, so this is impure copper, and this copper actually comes off the electrode, comes off the anode, and will go over to the cathode, and the cathode then becomes a really big thick electrode of pure copper, and you get a really nasty, let's just draw it in here, little sludge pile formed at the bottom of all the impurities that were in the copper. Okay, so we can purify it. The other thing we can do, if we just look down a bit, is again, we've got a positive copper anode, and those copper ions are going to travel through the copper sulfate solution and over to the cathode, and they're going to cover it in copper. So you end up with copper plated items, and you can do this for any object really. It doesn't, in this case we've got a metal key, so long as it is metal. Quite often you use nails and you end up with a copper covered nail at the end of the lesson. Unfortunately we can't do that today, but what we're getting is the copper ion coming off the anode and travelling over, and the cathode becoming coated with pure copper. Okay, Year 10, so just looking at what you have to learn for this topic, which is here. Okay, we have covered all of this apart from explain the formation of the product of electrolysis. Okay, so copper chloride solution, so it's in water. So we've got to decide what's more reactive, copper or hydrogen. Hydrogen's more reactive than copper, which means copper will be made, and chloride is more reactive than hydroxide, so chloride's going to be made. Sodium chloride solution we've just done. Sodium sulfate solution, again that's going to be the hydrogen and okay, so as the sulfate is the most reactive one, it actually breaks down and gives off oxygen gas. There are quite a few videos of people doing this experiment if you wanted to watch those on YouTube as well. Unfortunately we are a bit pushed for time at the moment. Again, this is one of those ones that you'll be able to do in the lab and we can go through. Fourth one, water acidified with sulfuric acid. Acidified water just breaks apart more easily. Okay, so again we're going to get